Hi, today we're going to be talking about internet-wide scanning. But first, let's think a little bit about the problem. What does it mean to scan the internet? Typically, when people refer to scanning the internet, they mean specific domains, or maybe the entire IPv4 or parts of the IPv6 space as well. Today we're going to focus on the IPv4 space, as it's an easier problem to tackle. And we're going to look at the problems that arise from scanning the IPv4 space. We're going to look at how to do it, which tools are available, and how you can do it at home as well, if you'd like to. So let's think a little bit about our problem. We've got our internet-wide space, which is made of 4.2 billion IP addresses because we're just focusing on IPv4. We've got typically two protocols, TCP and UDP. And we want to look for a certain service. For our example, we're going to look at, say, port 3389, which is typically used for RDP. So how do we go on about scanning the entire internet-wide space? Well, there are typically two types of actions that you want to do. One, you want to check if a port is open. And then you want to, two, identify which service is running on that port. And why is it important that we break this into two actions? Because one of these is extremely fast, detecting if a port is open, of course, and one is very slow, which is doing service identification. Why is that? Because to do the port open check, you typically just do the associated protocol type of connection. So for example, for TCP, you do the handshake, you send a SYN, you receive a SYN ACK, and that's it. You know that the server responds and that port has something running on it. For UDP, there's no handshake and you need to send the right probe to get a response. So what you want to do typically is you want to run the fast action on the 4.2 billion set, which then generates a subset with whatever IP addresses had port 3389 open. And there you want to run your slow action on that said subset. So let's take a look at an example of doing this type of scanning. In my case, I'm going to use the binary edge platform using the on-demand scans capabilities that we have, but it should show the different steps across scanning. Let's take a look at launching an on-demand scan using the binary edge API. This will allow us to see the behavior that I meant about the fast part and then the slow part. So what you're seeing on the screen, on the right, I am going to connect to my custom stream where the jobs will show. And on the left is the command that will launch the scan. So we're going to modify this a little bit. And I'm going to quickly break down what these different fields mean. So we've got, of course, the URL of the API. And then we've got a description field where essentially it's just a name for our job. We're going to say Portugal RDP because that's the country that we're going to look at. It's going to be a type scan, and what the different types are don't really matter for this video at this point. The target we're going to change from the IP address 1.1.1.1 to PT, which is the country code for Portugal. We're going to want to use the RDP module. So RDP. And we're going to target port 3389. So I'm going to connect to the stream. I'm connected now, and I'm going to press launch here. And this launched, it gives me back a job ID, and soon enough we'll start to see some results show up on my stream. So what do these commands actually do? And we're starting to see some things come in here, and you can see I'm going to stop it for a second. And essentially what you're seeing here is the port scan phase. All it's telling us is that we scanned from this IP address, targeting this IP address, and that it had the port 3389 open. And as you can see, all these events look fairly similar because it's just testing for port open. And then at some point, we're going to start seeing some events of the module RDP show. And we're going to wait a little bit for that. Let's see if we can start seeing some events show up. There we go. We're starting to see some of them show. For example, one IP address had RDP but with NLA. I'm going to grep by RDP so that we only see RDP type of events. Okay, I'm gonna stop it now. And we can see that when the module RDP runs, we get things like the screenshot, for example, as we can see on this line. So this IP address that belongs to the client binary edge is located in the US, associated with this job ID on this timestamp, had a result that the connection was closed cleanly. It took a screenshot. I can open the screenshot here real quick. And we can see that it indeed took a screenshot. And that's what you get. So we first did the scene scan, we checked which ports were open, and then the module that is much slower only runs on the IP addresses that gave a successful response from port 3389. But what is the entire procedure behind the command on the left, the launching of a job? And that takes us into the second part of this video, where we're going to talk a little bit about the architecture of doing internet-wide scanning. So what happens when I press enter on that launch job command? When I press enter, my curl command is talking to the binary edge API and essentially saying, here's my target, here are the modules that I want to run, here's my token to authenticate, and the binary edge API receives that, confirms that it is indeed an authenticated user, sends the targets, returns the job ID, generates a random job ID, which you saw in the video, sends the target to a secondary component still inside the job manager that splits however many targets exist into small batches, small tasks, looks at how many minions, and minions are essentially the scanning agents that we have that are associated with the user binary edge, and starts distributing all of these mini tasks across all of those minions. This allows us to do a bunch of different things. One, completely distribute all of our scanning. Second, if we want to do a scan much faster, we can just dynamically allocate more minions onto a specific user. It allows us to fully randomize where those scans are coming from. And this is very important because we've seen multiple situations where if we hit a target from just one IP address, we end up getting blocked, or we have huge data quality losses as well. The moment those minions start finishing some of those tasks, they return the results. The results are fed into a stream, into a database, into an archive, and the user can consume them in any way that they want. These scans are fully customizable. We are allowed and allow our customers as well to deploy custom modules as well. So we've got companies that do malware research where they deploy custom probes to detect malware. And it's fairly open framework. Any language where you can receive as input an IP address or a CIDR and output JSON, we can deploy it on the platform. And that's really, really cool because for any new vulnerability that comes out, any new thing that we want to scan, we can just reuse like some scripts that exist on GitHub whenever they get released, the POC scripts, or we can just use whatever has been community built rather than build from scratch. This has been our first episode. I hope you enjoyed it. I hope you liked it. Subscribe, share, let me know what else you'd like me to talk about. And now let's take a look at our random finding of the week.
This week on the news, there was a report of an attacker that is replacing, for a certain subset of database technologies, is wiping those databases and replacing the tables and the databases names with the word Meow. As we can see on the screen, it was reported that around 10,000 were found in different platforms of internet-wide scans. So how would we look for that in binary edge? And this is actually a pretty cool thing. We wanted to make sure that we were seeing the same, so we would look at type Cassandra or type MongoDB or type Elasticsearch, all of these within parentheses, and then for the word Meow. And indeed, it is confirmed that we are seeing this. We see over 20,000 databases that are already affected by this. And this is something that we're seeing day over day. We actually turned on daily scans for these technologies, because we're seeing that every day the attacker is compromising more and more databases. And this is our cool finding of the week.